Last time we saw the parent shapes. The parent shapes are steric number 2 linear, steric number 3 trigonoplanar, steric number 4 tetrahedral, 5 trigonobipyramidal, and 6 octahedral. And these parent shapes generate the other shapes of VSEPR shown on the next slide. Let's say you have, from counting your central atom and your peripheral atoms, let's say that you have a steric number of 3. Well, if you've got 3 peripheral atoms, that's trigonoplanar. But what would the geometry be if you only had 2 peripheral atoms? Let me repeat the question. Steric number is 3, but there are only 2 peripheral atoms. Put in chat what the name of the shape is. Put it in chat. It's bent, and I call that the parent minus 1 structure. So, although steric number is 3, it has the electrons to have 3, only 2 sides are on. What you do is you take the trigonal plane, the equilateral triangle, and you remove one of the sides, and that makes it look bent. Same way, steric number 4, but you only have 3 sides. What's the geometry? Put it in chat. Trigonopyramidal. And if you take yet another side away, it will be bent. Octahedral, when you take one side away, it's a square pyramid. And when you take 2 sides away, they're from opposite sides of the octahedron. That's the square. And the most complicated is steric number 5 because there are 2 types of sites. And you may remember last time that I said that the most electronegative atom goes axially. And an atom that's not there is really an atom of incredibly low electronegativity. So an atom that's not there is the opposite of an electronegative atom. That means atoms that are not there go, put it in chat, equatorially or axially. If electronegative atoms go axially, atoms that are not there, which are the opposite of electronegative atoms, go where? Equatorial or axially. And they go equatorially. So you take one equatorial side away from a trigonal bipyramid in steric number 5, you get the seesaw. 2, you get T-shape. And 3, you lose all the equatorial sides, and it becomes linear. And in time, you'll have these shapes actually memorized because you'll just be using them so often because VSEPR is super important. Let's practice a few systems. BF4 minus. Boron starts off with how many electrons? 3. Neon's 10, fluorine 9, oxygen 8, nitrogen 5, carbon 4, boron 3. Fluorine donates how many? 1. So that's a total of, put in chat, how many electrons? Remember that the whole thing is minus charged. BF4 minus, put in chat what the steric number is. BF4 minus, put in chat what it is. It's steric number 4, because 3 for the boron, 1 for each of the fluorine, 1 for the minus charge. 3 plus 4 plus 1 is 8, divided by 2 is 4, and so the geometry is tetrahedral. But let's look at water, H2O. What is its steric number? Put it in chat. Oxygen starts off with how many valence electrons as the central atom? Put it in chat. 6, each hydrogen gives 1. Its steric number is 4, 8 divided by 2. But water does not have 4 sites. So what is the geometry of water? You start off with steric number 4 and you go to the parent minus 2 structure, which I show here. The parent minus 2 structure for steric number 4 is bent. Water is bent. Let's do SO4 2 minus. So, how many valence electrons does sulfur start with? 6. Because argon is 8, chlorine 7, sulfur 6. How many electrons does oxygen donate? Oxygen. How many electrons does oxygen donate? Good, 0. So that's a total of 6. Minus 2 is 8. SO4 2 minus, which is the sulfate ion, is tetrahedral. let's do one more. HCN, which is hydrogen cyanide. And so let's see. Carbon is the central atom. How many valence electrons on carbon? Put it in chat. How many electrons on carbon? 4. Hydrogen donates how many? 1. And what does nitrogen do? Put in chat what nitrogen does. Put in chat what nitrogen does, please. And so that nitrogen takes 1 away. That leaves us with 4 electrons divided by 2. Steric number is 2. HCN is what shape? Steric number 2 with 2 things? Linear. And it's now known that the noble gases, the heavy noble gases, can be made into compounds only in conjunction with extremely electronegative atoms like oxygen and fluorine. Xenon starts off with 8 valence electrons. Please figure out the shape of xenon F4O. I'll give you 30 seconds. 30 seconds. Xenon F4O. A few more seconds. So xenon F4O is steric number, put it in chat. Xenon F4O is steric number 6. 8 for the xenon. Fluorine gives 1, oxygen none. 8 plus 4 is 12, divided by 2 is 6. And there are only 5 things attached. This is therefore, do you guys remember? Steric number 6 with only 5 things attached. Do you remember the geometry? It's the parent minus 1 structure. It's the square pyramid. And the rule is for square pyramids, the apical site, the site at the top of the pyramid, is the more electropositive atom. Oxygen would be on the top. And let's just do one last example, which will be I3 minus. First, before we go to the next slide, just iodine. Iodine is the central atom. Has how many valence electrons? Iodine is right next to xenon. Good. Iodine has 7 valence electrons. And iodine as a peripheral atom donates how many to the central iodine? To the central atom. Put in chat. Donates 1. And so let's do this last example. I3 minus. Figure out, please, what its steric number is. And if you can remember what its shape is. The steric number, and if you can remember the shape. Please put it in chat. So, iodine starts off with 7 electrons. Peripheral atom iodine gives 1, that's 9. There's a minus charge 10. So this is steric number 5. Steric number 5 with only 2 things attached to the central atom. That's parent minus 3. And if we look at that structure, it's linear. I3 minus is linear.